Good evening. Hello, everyone. Welcome to April 2023 AEVA meeting. Lovely to see you all again. Hope you had a nice Easter. Everyone wants to hear about this, so I'll crack on through my thing pretty quickly. And we'll hear from the QUT guys. Let's go, mate. Okay. Yep, you can go next one. EV infrastructure, my favourite topic, you know. The free chargers. Have you charged here recently, Jeff?
Yeah.
Is it online?
It was when I was there.
It was?
Yeah.
Yeah, okay. PlugShare seems to show that it's very unreliable. Multiple people saying it's not online, but nothing changed otherwise. They're all still free. You guys ever see EVs here?
Yeah.
Yeah, it's free, so, you know, get hammered by the Uber drivers. There's one still out at Mount Omni. Next slide, mate. We had a EV catch-up at the car park there. This is not the picture from then, but the check-ins on PlugShare have slowed down, so I don't know whether that's just people not being as prolific with doing that, but it was quite interesting. See a different charger. I think we managed to get about 50 kilowatts at two cars at the same time. So it was online. It had been showing offline a couple of times already, but one interesting thing was that it seemed to only allow single charging after like 7 p.m. or something. It got to like a time and then you couldn't plug in two cars at once. So it did have a little thing on the screen saying grid supply limitation or something like that. So yeah, slowing down. But the user interface on that actual charger is far superior to the Tritium chargers. It shows you the graph. It's much nicer. But yeah, that one's still online if you're out that way and you want a free charge. We have a few new sites. You really are taking on Les's role, aren't you? Yeah. Proserpine up in North Queensland now has a 350 kilowatt charger and a 50 kilowatt charger. You know, there's none in Brisbane, no 350 kilowatt charger in Brisbane. No, Proserpine has a 350 kilowatt charger, you know. But as I was reminded when I was talking to a few friends about it, that, you know, this is a corridor to Cairns and the like. So it's a nice location by the look of it, 60 cents a kilowatt hour. Whoa. I don't think the reliability of the 350s has been that much of an issue. Oh, okay. And I will admit though, when I was looking on PlugShare, there was some times where the superchargers weren't working properly either, but they were fixed very quickly, and that's the thing. It's the downtime that hurts, isn't it? So good to see another 350. They just should put some more in Brisbane. The BP at Maroochydore now has a pulse. So BP are really going. They just put one in Nambour last month. Now they've got one at Maroochydore. The same dual CCS. So we're really starting to see way less Chartamo CCS plug rollout, especially from BP. So they only got the one at the twin BPs on one side. So yeah, we'll see. I guess see what happens in that space. A new Tesla supercharger at Rochdale went in very recently, about a week or two ago. Like it was in, but it's become active. 6 stalls.
Where is it?
Rochdale, the Coles at Rochdale.
Just off the freeway.
So
Like opposite on that.
it's not Rochdale. So you got Springwood, you got Woodridge, Springwood, Rochdale, and there is information out there that Tesla are also putting one in at Bundy, Miriam Vale, Rocky and Mackay. So that is going to be a nice improvement for redundancy, reliability for getting to Cairns for those people who travel that route, because we know that Bundy to Rocky period stretch has some reliability issues with the tritium chargers. Victoria Point is getting a dual 50 kilowatt EV, so that's new to plug share. Not open yet, but
Dual CCS again?
they don't. EV don't do any dual CCS. They do all charter mode. I'm pretty sure these only do one charge per stall though on these ones. Yeah, you can't. This doesn't have dual charging, but it's 50 kilowatt per stall, so you don't have to share anyway. Okay, I did present this the last couple of months, but just another rehash. We're still waiting on Caloundra. That EV site there is the actual property that it's built on is been a pain, and they're not letting that get upgraded or roll out at the moment, or it's a network issue. But that site's actually finished, it's just not active. Haven't seen much progress at the Bribey one, and the Esk one has been in plastic for months now. The Toowoomba guys have been letting me know updates on that one, but still it looks like they just need to take the plastic off and open it. I can't see what the actual delay is with that one, but it's been there since October, November, so I'm not really sure.
Someone's got a comment on it. They said that they were doing upgrades to power.
Yeah, you probably want 50 kilowatt out of your 50 kilowatt charger, right? So there's no update on the phase 3 of the Quesh. They're all pretty much the same as last month. We're still waiting on these red ones to get installed, so I'll let you know about that next time. And I've updated the hydrogen thing from last month, so yeah, $15 for 1 kilo. And there was no price changes other than, I didn't change unleaded there. Oh, my bad. Unleaded is now $2 a litre, $1 per kilowatt hour. So I missed one up there, that's all right. Diesel is now cheaper than petrol, so yeah. But still much, much more expensive than having an electric car. A little bit to cover in the EV events. The Gayndah, who's braving the Gayndah Orange Festival? It's all right, I'll go there by myself. It's all right. All right, I think some Sunshine Coast people are going to join me, but Francisco, are you going? You're going to brave?
I have to see if I'm allowed to take it.
If you're allowed, okay. Yes. 600 kilometres in one day. I know it's a big trip. It's not for the faint of heart. I don't actually want too many people to go, but I want a lot of people to go because I don't want everyone stuck at Gympie on the charger all at the same time. So we'll get a few cars out there. As long as you know that it's on, send me a message if you're brave, okay? On the 2nd of May, down on the Bayside at the Bush Pantry Cafe, there's a morning tea, EV coffee and cake. It's on Facebook. If you want to know any more about that, let me know. Next hall meeting's on the 17th of May, third Wednesday is normal.
Just after that, just after the 17th and the weekend of the 18th is the Brisbane Truck Show, and that's going to have lots and lots of electric trucks at it. So it won't be something that we're particularly doing, but I thought I'd add that in there.
Yeah.
So if you're interested in trucks, then...
Is there an event on Facebook that you can put on our Facebook page?
It's the biggest truck show in Australia, so it's massive. It's at South Bank, and yeah.
Is Janice going to be there?
Big metal. Everybody's going to be there, and most of the main manufacturers are going to be launching electric trucks.
I saw Janice were doing a triple, whatever they're called. Not a B double, but triple. Is it a B triple? I don't know. Whatever a triple is, but 146 tonnes or something. 150 tonne. So.
18.
But all right, there's a few North Queensland events coming up for, well, Central and North for those that are watching online. One at Rocky, Gladstone and Bundy. If anyone's interested in more details, they can contact me and I'll put you in touch with the guys. But they do this each year. They have a little council coordinated EV get together. So yeah, just maybe pop a note on the YouTube comment section or just send me an email. Once again, the Noosa EV Expo and RAQ Motorsport in June, Cleveland EV Experience in September, and we will start at a certain point. I promise, Gary. We'll start at a certain point. I'm pretty comfortable with how this year will go based on having done it for 2 years now. But we'll start, maybe, we'll definitely have a meeting in May. How does that sound? All right, I'll help you. Okay, and we've mentioned the Bridgestone Solar Challenge before, down in October. Is there any other events I've missed that people know about other than the truck show? Just while I'm on this one, I might just, I got a little note. This Sunday, Drive TV, about 1 o'clock on Channel 9, is doing a half-an-hour show on EV conversions, including the DeLorean down south. So if anyone's interested in that, Channel 9, 1 p.m. on Sunday. All right. I've mentioned this for 3 months now. I think everyone gets the hint. Let me know if you can attend. That's all.
I drove my new Model Y to Newcastle and back over the Easter break, and I was really surprised and delighted that it's a solid 400 kilometres of range in a rear-wheel drive Model Y, 100% to 0% on a highway, driving down the Pacific Highway. So you can do that trip. I could do that trip, one stop.
What speed?
110. Like
110, yeah.
Speed limit the whole way. Yeah. And
No one does a speed limit though, do they?
Full car,
With 4 people?
Four people, 2 adults, 2 kids, and the whole entire car, every single nook and cranny filled to see, just holiday crap. So it was really impressive. I thought I was blown away. So I just thought I'd share with you.
Is that so? You extrapolated 400 by doing like 350 and a bit left over, and then
I did the full 400.
you did the full 400.
Well, I did 387 or something, 5 or 7 to Osaba,
Yep.
first supercharger, and I had 4%, and that would have got me.
That's pretty good. And you were 100 when you left. Okay, pretty good.
I just thought it was like, wow, this is, and what it was amazing is that that's a significant amount more than my Model 3,
Yeah.
which is
Smaller.
330 or something.
Yeah,
like
330.
that. So
What are the battery pack size differences?
it's a little bit bigger.
55.
The overall consumption on big long highways in Model Y was under 140. It was 137, 131. That was
Yeah. Kona efficiency, mate.
Mate.
A little bit higher, but I won't rub it in.
No, that's right. But no, I just thought, with that, it's like efficiency's king, and
Are we back?
all EVs, and that was pretty wild, pretty efficient.
Okay, just a couple of items and then we'll get the QUT guys up. The Ford Mach-E is coming to Australia at the end of the year, maybe just into the new year. As well as they've announced Puma Transit and E-Transit. The Polestar 4 got unveiled at the Shanghai Motor Show, and it's expected next year. And I think that's a really nice looking car. I don't know. It's got a bit of BYD look about it, doesn't it? So Francisco has to upgrade his BYD to the Polestar 4. But 90. Okay. If you're using the exchange rates and stuff, or I hate when they do that. Where's Mark? He wants to talk about Tesla Cybertruck. Tesla Cybertruck. Are you going to say anything? Yeah, you, Mark. Yeah, you said you wanted to say something about the pressings. Yeah. Anyway, so this is a 9,000 kilo press that they're using. I think it's the biggest press in the world. 9,000 ton. Did I say kilos? 9,000 ton. It's his fault. It's his fault. 9,000 ton press. Right. What's the next slide, mate? Because I thought I'd help Mark out. Is this like a picture of what you want?
That's what
Are you just scrolling through your phone? You want this picture or?
I've got this is by magic.
Yeah. Okay. But how are we going to get it up here, mate? Yeah, I know. But you sent that to me at 11:30 at night after I'd already sent the presentation. So.
They were testing. They're a few months old.
Did you want to say anything or?
Some of them are crashed in the sideways.
Yeah. So, are you going to say anything or you want me to say something? I don't know anything about this, but Mark was telling me that a lot of these are Model Y and Model 3, or I'm assuming mostly Model Y castings. But some of these are actually the Cybertruck castings because they're different. I don't know all the stuff Mark knows about. I went and checked out his setup for 3D printing. He was showing me all about the drone footage of the Gigafactory. So this is the type of thing that they do. But is there anything interesting to know about these pressings? Okay. I thought you wanted to say something.
They are the front casting. They are bigger and beefier than the Model Y ones. We put them side by side.
Okay. The Cybertruck's bigger than the Model Y though, isn't it? So, okay. All right, no worries. Moving right along. There we go. Let's go. We've got Tom and if you guys just, sorry I've missed your names again. Just speak into there. It's 3 mics, mate.
Perfect. So I'm Tom. I'm the team principal of QUT Motorsport. I have Jacques with me and Tyler. Sorry. I swear I've known Tyler for years now. Oh, out of the thing. So we're from QUT Motorsport and I thought I'd present the art of autonomous vehicles, our journey from a driven electric vehicle to a completely autonomous driverless vehicle. So who are we? We're one of the leading electric and autonomous FSAE teams in Australia. So FSAE is the Formula Society of Automotive Engineers. And we have over 100 undergraduate students spread across all different disciplines throughout the university. So I think I've got all disciplines in the club except a lawyer and an architect. So if you know a lawyer and architect who want to get involved with our motorsport team, let me know. And we're based out of QUT and Gardens Point, so Queensland University of Technology. Next slide, please. So this is Lando. Now, who is Lando? So it's our third generation electric vehicle. It's fully autonomous, although at the moment we have taken the computers off because it is back to its driven state. So we're doing some testing and validation with it at the moment. Once we finish all that, we'll pop all the computers and sensors back on and it'll be back to driving itself. So it has 4 independent hub-driven motors, so we can get 60 kilowatts out of it, and it sits us at about 80 kilometres an hour. It's got a single-piece carbon fibre monocoque. It's one of the lightest I think it was even the lightest in the competition at 25 kilos, so we're very excited and very proud of that. It has a full aerodynamics package and suite. And then it also has a wireless telemetry link, so we can get all of our data. As you see at the Formula 1 events or any of the race events with their big telemetry setups, we can get that exact same data sitting from our computers nice and safely in the pits. And this is some footage of it back when it was driving. I think if you click again, it might play. That's all right. It's doing what we call like some of our torque vectoring. So with the 4 independent wheels, we can actually maneuver around. So if you see those 2 blue cones, we actually maneuver around the corner and through that S-bend there. So it's quite impressive what we can do. We can come back to that maybe. So one of the big components that makes up our driverless team and the driverless section of our team is the autonomous research that we facilitate through the team and then collaborate with other teams. So we have a significant number of thesis projects that get conducted every year. So thesis project is one of your honours year sort of research project you have to undertake. So most of them are over 12 months duration, and then you produce a journal paper at the end of it, and it gets published. So, so some of the projects that have happened over the last couple of years. So they developed our initial SLAM implementations and sensor algorithms. So that's how we take all of our sensor data and collaborate it together, overlay it on each other, and then turn that into something that the car can understand as a map. And then it also laid the foundations for a lot of our key autonomous components. And then tying in with industry and other teams. So we have very strong relationships with our industry partners and sponsors, as you can see, all over the car. And so it builds off a lot of their existing learning and research that they've conducted. And it's great to be able to consult with them and tie into a lot of their innovations as well. So this is sort of how it all starts. So this is not Lando, but it was one of our early mock-ups, and thinking about how we can get the sensors onto the vehicle and where you can put them, and sort of what the impact they might have. So a big thing we push is rapid iterations and failing quickly. So with our all the university CAD work and sort of 3D printing, additive manufacturing, we've been able to very quickly prototype both sensor design and placement. So we can go, oh, well, a laser sensor might look pretty good if we put it up the top. So we'll make up a quick acrylic bracket, check that it works, and then once we're happy with it, we can send it off and get a sturdier bracket manufactured, or a 3D printed bracket might do the job. So as you can see, we do have quite a lot of 3D printed parts on the car. And that was one of our early prototypes in the corner. So what you can see here is our steering linkage. So this attaches our autonomous servo, or the driverless servo we use, into our existing steering setup there. And that's how it started, was just as a 3D print. We were able to turn that around in about a week. And then the final product, we were able to get that machined. And so it's still utilize it to this day. So some of the prototyping and simulations we did. And we just lost that. Oh.
There's a process.
Brilliant. Did you want to talk about sort of what's going on here, Tyler?
I can if you want.
Yeah, absolutely.
So what's happening here is this is our test setup for the cameras, specifically the LiDAR. So the way a LiDAR works, I'm sure most of you know, it's a rotating camera, and it's light sensing. So it sends out a beam of light, reads back the time it took to get that point back, and that's a 3D map of your surroundings. So the way we use LiDAR on the car, it sits at the front, and then we use it to get an exact map of where our cones are. So the car needs to be able to know exactly where the cones are, because a little bit of error can throw the car off the track. So at the moment, before we had our whole setup going, we put the LiDAR at the same height on this trolley as we would have it on the car, and we ran through multiple simulations of where the cones would be. So it was reading, so we were getting data and throwing it into our machine learning systems and mapping that. And it took a year to get to where we are now with sensing LiDAR and mapping our surroundings as quickly as we do now.
Thank you very much. And then this is some of the telemetry, what I was talking about. And so this is our software in the loop setup that we have. So we can actually run all of our models and algorithms locally on the machine and play back some of our recorded data, and then also give it brand new simulated data. So we can basically put it through any sort of scenario we want and see how it will react. So as you can see there, that's the simulated onboard footage in the top left-hand corner, and then we've sort of got a third-person overview, and then that's the mapping going on in the top right-hand corner. So it's figuring out exactly what the track looks like, and then we've got one of our SLAM mappings with some of the cones in the middle there. And that all happens live on the car. So as I mentioned, we have a failing fast mentality and approach. So basically, just to start with, we strapped everything on the car, as you can see in the bottom left-hand corner. So it was very rudimentary, and we had our electronics and computers just sitting in a typical hardware box you'd buy from the shops. So it enabled all of our early testing and allow us to figure out exactly where we needed to push our development and focus our bandwidth on. And then recently, this was our demonstration for BMW Germany. So we had one of their representatives over come out and do quite an extensive lab tour with us. And this was, for those that know QUT, this was the kidney lawn out the front. So there's a big lawn just before you get into Brisbane City. And we shut the whole thing down, and we were able to drive up a section of that. So next year, we're going to drive around the whole lawn, and we'll shut the whole front of the university down for that. So very excited for that. Next slide, please. Jacques, do you want to talk about some of the challenges we've faced?
Yeah, so challenges throughout this, one of the major ones has been our EBS, so the emergency braking system. I think the most prevalent one we've probably come into in the last few months has been how big it is. I think at the end of last year, we went into a few issues of it has to hit a certain, like you have to slow down at a certain speed, and we weren't hitting that, so we had to redesign it within about a week's, or in a space of a week, manufactured in a space of another week, and it was back in the car for testing for competition. And it passed that, which was really cool to see. And so more recently, as we've been converting it from driver and driverless, we've been seeing that, as you can see, it's quite a bulky setup to get out the front of the car, and so you have to really take it out and so on. And so looking into the future and the things that we're designing at the moment, we've actually managed to adapt it to just one of the brake, like just the brake pedal, rather than it being a whole setup behind the entire pedal system. And so that will allow it to be one lighter, so we can go quicker, but also two, much more easier to access and hit all of the design goals as well that we need to hit for competition. So yeah, that's some of the challenges there.
Thank you very much. And then, yeah, as Jacques mentioned, we're currently redesigning that, so we're on our third iteration of that, and that's all been within the space of sort of 12 months, so really iterating very quickly. So some of the challenges we've faced along the way is Lando was not originally designed for autonomous application. So as we would have seen in the video, it was a driven vehicle, and then it was retrofitted with all of our driverless computers and sensors and hardware. So then taking those simulations and how do we actually turn them into real world applications? So how do we take that data and make sure that it's useful? And then along with all the unexpected bugs and problems that you normally associate with software development and hardware development too. So there have definitely been a few spanners in the works. This was another video too, I think. Maybe just a photo. Yeah, or if you just go back one slide, please. We can see we have one of our, I might need to go back twice. So this was one of our early demonstrations where we have that simulation I was talking about, and that's actually feeding back through our hardware, and we can see how it reacts to it, and then form that full integration loop. So we can go to the next slide. This was another video. It has another light on top, which tells us when it's in an autonomous mode or not, so basically when we can approach it or when we need to stay back. And it was a very, very early morning, one evening, getting towards competition, and we turned it into a little bit of a rave party. So that was that video. But, next slide, please. So the final product. So as you can see, this was Lando. This was at our industry night a couple of months ago. And so the sensors that are on the vehicle, we have a full 360-degree LiDAR. We have a 3D depth camera, which is mounted at the top above the seat cushion. As a GPS and IMU, it has a heartbeat emergency brake, so that EBS that Jacques was talking about. If we lose connection with any of our vehicle control units, it shuts the car down straight away. And then along with our various vehicle dynamic sensors. So as you can see on the vehicle here today, we have a number of suspension potentiometers, and we also have a pitot tube which goes on the front so we can measure airspeed as well. Next slide, please. There was another video, but that's okay. So some of the software algorithms we've also integrated has been a custom machine learning model. So for those that know anything about machine learning, that's built on the YOLO algorithms. And then we have our LiDAR regression and clustering algorithm. So it's one thing to take basically points in space, but how do we actually pull data out from that? So if I was to scan the crowd now, I'd see lots of individual dots, but how do I turn that and associate that and go, well, those are people. And then our path planning algorithm, so how do we effectively get through our mapped course as fast as possible, figuring out those racing lines. And then, as I mentioned before, our SLAM localization. So taking all that data, tying it together, and then every lap making it faster and faster and faster. Next slide, please. See if this one plays.
We will play the videos.
No problem. That's all right. Well, we can come back to this one. So some of the other work that the team has done, so we have our new gearbox in the top left-hand corner. So these motors we custom designed and had them machined in Australia. Then we sent them overseas to Germany, and they had all the windings and magnets installed in them. And then part of our ongoing work at the moment is the planetary gearbox that ties that all together. So the motor spins at approximately 20,000 RPM. So how do we actually convert that down into a usable ratio? And turn that electricity into kinetic power. So with our topology optimized uprights in the middle. So our typical uprights as you would have on a vehicle, except you go through and you calculate only where you need material. So if it's not receiving any force, then there's no point in having material there, and we can make it a lot lighter. So as I mentioned, our 20,000 RPM, 36 kilowatt electric motors. And then on the top, you can actually see some of the 3D printing. Those cooling barbs, so they were all laser sintered, which was incredible. We had our carbon fiber monocoque, and that's part of the layout process there. So that's featured in both this vehicle and our new vehicle. We have our thermal simulations, which tie into a lot of our motor work and understanding, are our cooling solutions going to be appropriate? Are things going to get too hot? Will they melt? Will they break? We have all of our control electronics. So all of our embedded electronics are designed from the ground up by the team. They're in their third iteration now, so it's a very stable platform. And there's another picture of our carbon fiber monocoque in the bottom right-hand corner. So we're QUT Motorsport. That was a very brief overview of our autonomous vehicle. I think we have time for a few questions, if there are any.
We definitely have time, but if you want to see them...
Yeah, definitely. We can...
We'll try and play these videos.
Yeah, sounds great.
This might bring up a link to YouTube, are they?
They were embedded originally, but it may have linked them if the slides were downloaded.
There we go.
While they're working it out, does Lando know he's got a car named after him?
Yeah, he does actually. One of the Jacques can talk about this a little bit. Do you want to talk about the whole racing for Tom as well?
I can do, yeah. So I guess I'll give some background to why we've called it Lando. So in 2020, one of our team members unfortunately passed away to cancer. And so the team at the time did the only thing that they could do and dedicated this car to him and all the work that he had done for the team. There you go, there's a video of our car going around the corner. Yeah, it's pretty sick. And so we dedicated this car to him, and in doing so, we named it Lando, his favorite Formula 1 driver, and obviously inspired the livery from the 2020 McLaren at the time. And so within that, we actually sent the finished product to McLaren, going, we've dedicated this car to Tom, and his favorite driver was Lando. It'd be awesome if you could pass that on. And we actually got a video from Lando saying like the car's awesome and like so sorry about Tom passing away and all of that. So Lando does actually know we have a car named after him. Yeah, it is really cool. Yeah.
Yeah, it was very late at night.
So we're best engineering happening.
Oh, absolutely. I mean, officially our lab closes at 10 p.m. But our little secret. But I'm pretty sure, this will be another one that'll be worthwhile.
You know how you said that wasn't made for autonomy originally? Mm-hmm. How would you design it differently if it was?
Tyler, do you want to take this one?
Oh, that's a hard question, actually. I don't know if I've thought about that. To be honest, the biggest issue we had was integrating some of the electronics involved in the driverless system with our original electronic setup. So what we had originally was a bunch of different boards that did a lot of different things, and fixing that, like just as an electronic system, like repairing that on the go was very difficult. So I think early 2021, we completely stripped out the electronic system and moved to a distributed control system. So that's where our VCUs come in. They're boards that can be applied in any like where on the car. So I think we have 5 on this car, maybe 6 now. So you just, if something doesn't work, you swap it out with a new one and flash the software. And so that has made it a lot easier to add our driverless systems into, because the loop now is so much simpler. It's much easier to get the electronics and systems that we need on the car. So that's probably the biggest thing. The other thing, our control boxes at the moment, they sit on the wings. So we have like 2 massive white boxes that kind of sit on the wings when it's autonomous. So it's kind of, if we do, we can swap it out to like quickly turn off the switch and put a driver in there, but you do have the chunky boxes on the side, so I don't know if I'd race it hardcore while they were there. So that might be the other thing, is that we'd figure out a nice place to put those computers. And then what Jax was saying about the EBS, that's being redeveloped now as well.
Surely there are some questions.
Yep.
I just have 2 questions.
Yep.
With the LiDAR, so the software for the LiDAR, is that predictive or is that feeding the track?
Sorry, what was the question?
Is it predictive?
Yes.
Predicting the track based on the cones?
Yeah, so it's in the competition we have we do get 1 lap where we do it slowly and it learns the map, but that wasn't actually implemented last comp. So it is we do have a predictive system and then our control system. It kind of overlaps, but I don't know too much. I couldn't go in depth about it, but it is predictive. Yeah.
The second question is, how did you make the leap from driver to driverless?
Great question.
Yeah, it took a lot of work.
Yeah, definitely a huge amount of work. It's been like, a couple of years in the making now. It's sort of been working, chipping away at those things, and like the trolley we saw earlier, sort of putting those test beds in place where we can validate those electronics and control systems.
Yeah, it kind of is 2 separate systems. So once we turn the key on, it's driverless, and we have systems in place where, like, for instance, you can see on the, we have an e-paper on the screen of the steering wheel. We can put our driverless tests in there and our what we're testing, that sort of thing, our setup, but it is essentially 2 different systems. We turn a key and it's a completely different system.
But do you obviously somewhere along the way you had a car that couldn't drive itself, and then your incremental steps were for it just to move a meter by itself, with not necessarily sensing anything, just moving mechanically by itself, and then you started to adapt the data coming into.
It was kind of the other way around. It was the other way around. Yeah, so we started with the sensors. We did everything, like what we could, as much as we could with sensors before we even put anything on the car. It was all like, what do we see? It was all vision. Then we slowly went to...
Not on the car though? Like
no, not on the car.
Test bed or something?
Yeah, so like that system, it all started with vision, and then we stepped to steering. So the steering was the next thing. Could we actually steer the car? And the very last thing we did was braking. So that was getting the car to actually move. And before we could do any of that, we had to have braking in there.
So did you have like teams working on each thing in parallel so that, like, to speed up the process? Or did you do one challenge at a time?
Yeah, so our team's sort of made up of we have 5 sub-teams. So we have our driverless team, which specializes in our hardware. And then we have our electrical, mechanical, software, and business teams. And so each of them sort of chunks off a different part of the car. So, and then integrates a lot with each other. So a lot of the braking system is done in conjunction with the mechanical team, and then a lot of the control systems are done in conjunction with the electrical and software team. So then they're further broken down. So we use like sort of typical project management approaches where we have everyone sort of assigned a task and we have lots of different tasks going on. So we have our managers that look after all of that. So it's a bit of an unwieldy beast at sometimes with 100 members doing sometimes over 100 different things. But yeah, it's definitely broken down into lots of different
Any of the
tasks.
systems having crossover between the teams where you might be getting to a point where one team wants to do one thing and another team wants to do, or does it actually mesh quite well?
Yeah, we can sometimes get that, and ultimately you sort of have to sit down and look at the engineering factors behind it, and like what is the benefit we're getting out of this, or like there's definitely a cool factor in being a volunteer organisation. Like you have to take that into account. If people don't want to do it, then they're not going to be there. But it's ultimately we term it a team first approach, and what is best for our team. And with that mentality, you sort of take that to everything. So
Lots and lots of free hours.
yes, sometimes.
Who else got a question?
Yep.
You're saying you've got quad motor torque vectoring.
Mm-hmm.
Does each motor have independent traction control? So when you're torque vectoring, you can actually optimise, tank tread effectively. So when you turn it quickly, you can have one effectively decelerating, one accelerating to get you the closest. Is it per motor traction control, or is it system-wide?
Yeah. So that is per motor. Jacques, do you want to talk about this, or that's right?
Yeah, I can try. It's not exactly my area. My guy who does vehicle dynamics talks about it quite a bit, so I can try and tell you a bit about it. It is like sort of per motor, and so as you were saying, like say we're turning a right-hand corner, you want the inside decelerating and the outside accelerating to get around that corner. And so that's exactly what the algorithms and all that do to tell the car that we've got this much degree of steering, then the motors need to be doing these speeds to help us get around that corner as quickly as possible. That's about as much as I know about the system. But
So how do you know when the wheel is slipping then?
how do I know when what, sorry?
When the wheel's starting to slip. When the wheel starts to slip, you got to back off.
Yes, the car doesn't necessarily have enough power to do that. Like at no point has this car ever really lost traction, so we've not really had that issue.
But if you're going on a corner, the
Yep.
inside wheels will have less grip.
Essentially, yeah.
You should have it less enough.
Yeah, it definitely plays into the sort of.
You should be able to compare front and back because there's a different angle on the front.
Yeah, that was one of our, actually one of the first things they looked at, I think it was about 18 months ago, was one of the research projects into that is like how do we determine that and model that. So we have quite a strong algorithm which looks after all that. And one of our big things at the moment is our next vehicle will be two-wheel drive to start with, and then we'll progress to four-wheel drive. So it's how do we modify that and adapt that and make sure that works for that vehicle as well. So, yep.
And you've got really single tyres.
Yeah, absolutely.
So that'll make traction. The question I've got, we're kind of electric vehicle, although the autonomous stuff's interesting. Having some battery, how many cells, what kind of, a little bit around battery technology that are then feeding your four motors?
Yeah, absolutely. So the battery in here is 5 kilowatt hours, I think. So I wasn't involved a huge amount with the actual electrical design for this one, but I can speak for our new vehicle. So our new vehicle uses I think it's the 21400 Lion cells. We have 28 of those in our segments, we call them. And so they're 28 in series, one parallel, and that makes up one of our segments. So we get 120 volts out of a segment. So then we take those segments, we put 5 of those in series, and we get 600 volts out of that series. And then we take 3 of those 600 volt series strings and put them in parallel. So we end up with 15 of those bricks in total. So I think there's like 420 something cells. So.
They're positioned to actually for the weight, so you can actually adjust the weight of each wheel depending on where your battery tracks, or are they?
Yeah, so it definitely plays into it. There is a lot of like competition regulations as well. So one of the big ones is we have to be able to remove the battery for safety and so we can charge it. So it has to be charged outside the vehicle and things. So that definitely plays into it. But there is a lot of consideration, especially with our vehicle dynamics, and what we're looking at the moment is how do we effectively position everything to take that into account. So a lot of we use sort of a rectangular design for a number of reasons. Also for ease of assembly and safety, we can very easily disconnect our segments and pull them out and work on them, and then reinstall them. Some of the European teams will use like a flat design, and the other thing is we have 15 identical segments, whereas they might not have a single like segment in their battery that is actually the same as any other one, because they would fit into the nooks and crannies. So it's just weighing up those engineering decisions, what are the benefits. So
have you had any like really big challenges to overcome, or any significant like light bulb moments where it's like, oh my god, this is like, we thought it was going to be very difficult, we've managed to overcome that hurdle?
Building a race car. Yeah, that's a pretty big one. Yeah, they sort of.
Is there stuff that you don't know how to do?
Yeah, absolutely. That's. I mean, to be completely honest, we all kind of making it up as we go along. That's one of the big things we pride our club on, is like being one of the university's like premier clubs. Is we're not building a race car. We're like, you're actually looking at the engineering solution behind it and then following through and making those decisions.
And we're all we're all undergrads. When we start, we're maybe like first, second year. We know nothing when we start.
Yeah, so we don't know how to do anything really, and it's figuring out as we go along and tying that in. So we have a number of academic supervisors that work with us quite closely, and utilising those research papers as well to sort of leverage that and get those hours and that kind of perspective on it.
Well, okay, in the same thread then, is there things that you set as a goal to trying to achieve, and like have you managed to achieve things like that? Or are you like, maybe this is an idea, we do the research and then we implement it?
Yeah, definitely. So, things going in. I'll just wait for that. Yeah, I can take a hint. There we go. So yeah, there's definitely two aspects there. So one of the things that we have going on, especially with our like braking and drivetrain team at the moment, is they're looking at the foundation for sort of how do we incorporate custom calipers and other custom hardware into our future designs. Like, we might not be able to achieve it right now, but we do like a year or 2 years of research and get prototypes and get that testing, and then for that third iteration, then you can integrate that in, and then you get all the savings and benefits from that. Another area we're looking at doing that is with our inverters. So despite all the autonomous vehicles that are around, sort of 600 volt inverters, although it's quite commonly used voltage in tractor systems, are actually very difficult to find. There aren't many. So we have a QUT solution, a component off the shelf. So it's actually for like automotive and industrial solutions, but we utilise it for our motors as well. But one of our big research projects at the moment is custom inverters, so completely designed by our students. So with that, our first iteration has just been ordered like 2 or 3 days ago, the circuit boards for those. So the students working on those at the moment will integrate those and test those, and then they'll be taken over by the next set of research students who will look to do another set. So then in sort of 18 months from now, we can look at integrating them into the car.
So what would be maybe like an example, like if you go on, well, we want, I think you mentioned brake calipers, we want to run a bigger rotor so we can slow down faster or then accelerate or whatever. Is that the type of thing? What would be some examples of something you've researched and then implemented?
Yeah, did you want to talk about a little bit about our design camp, Sharks, and how that all ties into that sort of process?
Because there must be some research papers that you're saying.
So yeah, at the start of the year, we have a design camp, and essentially that's inviting our students plus students within the university into just legit. We turn into a big engineering firm essentially for 4 weeks, and there it's sort of the job of our team leaders to come up with essentially research projects. So a couple from the mechanical team this year was one, the custom brake calipers. A second one was a damper cage, so like the little suspension strut you can see there, putting a cage around that for our new car, which helps it when you're in like roll and turning. And so those are a couple of projects that we chose And people did research for 4 weeks. None of it was intended to be on our car. It was purely just, these would be cool things to look into if they turn, if the result of your paper is that it's a good option to go with. And both of those projects will be on our next car. And so that's sort of we had a vision of this would be cool to look into and research, and now they're at a stage where the suspension is actually going to be manufactured in the next month, and the custom caliper will go through a slightly more extensive process, which sort of comes to the research side where our academic supervisor has actually gone, I want to do like in-house testing with this, and so they've done the research, they've done the calculations on it all, they've got a design. We'll now manufacture that design. We'll test that on a test bed that they've designed, which is essentially just the caliper on a rotor, and we'll spin that rotor to certain speeds and basically try and destroy the caliper to see if it's matching our simulations. And so that's sort of where that's going. And then eventually, assuming the testing is successful, that will end up on our car in 12 to 18 months' time.
Do you have research aspects where you go, that just didn't work at all, or
we've sort of we've had certain ones in the past. For example, our aerodynamics. We've had a few different people look into your simulation, which is essentially a simulation of the car turning, which is where your aerodynamics matters the most, is in a corner. But to simulate that at an undergraduate level is quite a complex task, and I know 2 or 3 people now who have attempted it in slightly different ways, and none of them have been successful. So it's still one of those, like, okay, we know it's still something we want to look at in the future, but hasn't worked out, so we're sort of going to put it to the wayside and focus on, okay, we know we've got our straight line simulations really well at the moment, and so we're just going to focus on those and refine our project that way.
I know you've probably got a different formula that you have to adhere to, but do you take any inspiration from Formula E?
Formula E? Yes and no. I guess from a mechanical aspect, we sort of look to Formula 1 more than Formula E, but we look at all different race cars. The thing with that is that, like, for example, the Formula 1 cars, that the speeds that they go, we just never see that. And so a lot of their designs are designed to go, 300, 380 kilometers an hour, whereas we'll see a maximum of 80. And so our designs have to be significantly different to that of a Formula E or a Formula 1 or any other type of single-seater race car. And so the best inspiration we can find is the teams in Germany or in Europe that perform at a really high level. And you sort of aspire to their designs and their cars and take inspiration from where you can, and we try and better ourselves in Australia so that eventually we can take our car that's reliable enough over to Europe and compete with them and see if an Australian team can beat the Europeans.
Do you like wind tunnel testing?
To a certain point in Australia, we don't have a big enough wind tunnel unless you're in Monash and Melbourne, which they're closing that down because it's too expensive to run. So. We don't have any actual wind tunnels. We do have a really small one that's about yay big at QUT, and so you can put little models. We actually put a little model of our rear wing in there, and it only tells you so much though. So yes and no. Yeah.
Any other questions?
Yeah.
Where are the other teams in Australia and competition?
Yeah, for sure. So we have a competition in Winton, Victoria, at Winton Motor Raceway every year in December. And so pretty much every university in Australia, bar a few, have a team. And so in Queensland, our main teams are QUT, UQ, Griffith, and there's a 4th one being made somewhere that I can't remember right now, but Sunshine Coast, cool. Anyway, so yeah, we sort of design our cars over a year to 18-month period, and then we'll all converge at that competition where there are static and dynamic events. And so our static events include a business presentation, a design presentation, and a cost presentation, and we get scored on all of that. And then we will also do our dynamic events, which include like a skid pad, so you go in like a figure 8, an acceleration run, and then there's essentially like a time trial like sort of circuit, and then you also do an endurance on top of that, which is a 22k of the same circuit with 2 different drivers. And so that's all just based on how quickly you go through, and then you obviously scored like that. Yes, we've had a big disruption of COVID, so most of the competitions recently have been online. However, we did come second in 2020 on the online competition with the static stuff, so that was really a really big achievement for our team. Last year we came unofficially second in the autonomous competition because Monash. Yeah, so Monash dynamically and statically with the driver competition have won 9 out of the last 10 years. So yes, we are.
Well, you work quite closely with those people.
Yeah. So but yeah. So yeah, we do.
There's
Okay.
not a rivalry between you and
There is a rivalry, but it's a friendly rivalry. Like there's no hatred or anything to each other. We just want to beat the next person.
Or it's pretty close?
To an extent, like we'll share our ideas. We get a bit, like when it's our new cars, we'll get a bit closed off about it and not want to give away too much information. But when it's like this car that's been around for a few years, we're more than happy to tell them about the technologies that we've used because we know we're a bit ahead of them anyway, so it'd take them time to catch up. So we're more than happy to share that. But yeah, that's.
Where do we get to see it tried out?
Well, we've got...
Move the chairs back.
I wish.
That's why you brought it, right?
Yeah, exactly. So we've got a number of track days coming up in the next couple of months. So both our driven ones very soon, sorry, and then our driverless ones a little bit later in the year. So we'll make sure we get some videos up on our Facebook feed. And I think there are already some existing ones on our Instagram and Facebook pages, which you can check out.
Is this the current model, or is there another superseding one?
This is our current driverless vehicle. We have a new driven vehicle, which has got a chassis. It has a front uprights, has suspensions about to be bolted on.
Was that end of last year that one got released? Is that
Yeah.
November around then?
Yes, yeah. So, and that's all in the lab. It's currently getting built up. So, if you ever walk past the lab at QUT, you'll see it sitting there on our chassis stand, which is pretty cool. And then we'll just get bolting everything onto that.
But did they then build the next one of theirs that they want, and then you get their previous their model, and then you modify that one to be autonomous?
No, so the next...
Or is it just at the same time?
Yeah, no, they're at the same time. QEV4, this is QEV3, QEV4 won't ever be driverless. The next car will be QEV5, and the goal for that one is to be a combination of driverless and electric again. So that will be one that we can switch back and forth between driverless and drivered, and we'll race that as two different cars in one.
I guess, are you planning to do any improvements to the electrical side of the car, like the capacity or anything in that way, different voltage?
Yeah, so the upgrade from 70 volts to 600 is massive, and that will be, that in itself is a massive undertaking, and we've got to basically redesign everything in terms of what our system can handle. In terms of our low voltage shutdown loop, which is our main most of our electronics is our low voltage shutdown loop, that will all stay the same. There's minor upgrades, revisions on things for the most part, but it'll be that tractive side that has the biggest upgrade for us now with the 600 volt car.
I'm sorry if you already said this, but EVs generally have 12 volt in the battery pack. Are you running these two systems, or?
Yeah.
Is it 12 volt in a 70 volt or 600 volt?
Yeah, absolutely. So as Tyler mentioned, we have the low voltage side of things. So it'd be like running your communication systems as you would in a typical EV, and as it does in ours, and it runs all of our embedded electronics. And then we have our tractive system, which is what we term for our high current and capacity system. So that's completely isolated. So all of our communication to that is also all isolated. So they're essentially two different systems. The tractive system is floating in the car basically. It's not grounded to anything. It's not connected. Yeah, we do use CAN bus in there. So that's one of the really cool things with those vehicle control units is it's all over CAN and everything's over CAN now. So you can just drop another unit in really easily. So.
Any other questions, guys?
Yes.
Have you emailed Elon?
Have we emailed Elon? Yes and no. They run a competition every year for like for engineering students and for clubs, and it might actually be specific to Formula student teams. And it's to design battery monitoring solutions. So you propose your battery monitoring solution, and if it gets through, you get the opportunity to prototype it. And then if you win, they give you a whole heap of their Tesla cells, which they use, and along with some money and things. So it's, there's competition every year, which is pretty awesome. So
It look good on your CV.
it absolutely would, yes. That's,
Is that your goal? I mean, would you like to work with Tesla or
I think it varies. We have people that go everywhere, so out to all different industries. So we're quite lucky that a number of our recent alumni are working in those fields. So we've had people who are up at F1, and then we've got Isaac Baldry, one of our very recent alumni. He's working with 888 Racing, Red Bull and Pole Racing with the supercars. So he's one of their lead data engineers there. So you'll see him. If you see a big bushy beard on any of their social media, that's probably Isaac. So
This raises a good point. What is your goal overall? Is it just to win the comp, or is it like you're doing it for the love of it and to the learning of it?
I think it's all three.
yeah, that's one of the big things actually we've been asking ourselves recently is like what are we looking for in our new vehicles? Like why do we do this? And a big thing is it's cool. It's awesome. Like I think none of us would be here if we didn't love what we were doing. But then it's also to develop our students. So our students come out of our club, and I will very happily say better than any other student who has not participated in motorsports. The key skills that you get from that, sort of both on the technical aspect, but also the communication skills of working in a team, management, accountability, all those key skills that those buzzwords employers are looking for basically. So that's actually a problem we have with our sort of more senior students is they're already getting pulled away by industries. So it's like, oh, can you come work on the car? Oh, sorry, I'm in the office doing this. Or lots of different ones. Well, yeah.
All sorts of ones. I mean, Boeing is a big one. They take a lot of our students, but a lot of racing teams. They
Yeah, so we also have quite a good connection with BMW as well. So we have a number of our students over in Germany at the moment who are working alongside there. And then we've got a big study travel trip, which we've just received funding for, which will happen probably early next year. And we'll see 14 of our students head over to BMW to integrate with them for a couple of weeks. So.
Maybe one or two more questions and wrap it up. Go for it, mate.
What university in Germany was involved in this project?
Sorry, what was that?
What university actually?
What German university was involved?
There was BMW.
what German uni?
Oh, what German uni? Pretty much all of them. So the big one of our students is over with TUM. So Sorry? Hanover. I'm sure they definitely have a number of teams there. I know like pretty much every single university in Germany has a very, very good team. So they definitely have a university team there. I don't know anyone personally over there, but I'm sure they'd...
This is like a worldwide competition?
Yeah, absolutely. It's a worldwide competition, so there's teams all over the place. So.
I competed in it 23 years ago or something.
Yeah.
So
Oh, really?
Which bit did you make, man?
I was the one who you had the wiring work.
That is a very important part. Yeah.
We used to use a Hayabusa engine before this, and you can't do that, and it all happened, and it was all about driving. We competed at Langland, the old Holden track, and I was with the University of New South Wales at that point in time. But I was a tradie from a TAFE that came in to help actually make it because
Oh, wow.
the students were, looking for practical skills.
Absolutely.
Yes, mate.
I think we'd maybe take this as the last one.
Yeah.
Sorry.
No, yeah.
Go for it, mate.
So each versions of these cars, are you starting from scratch or are you trying to improve on the design?
Great question. So the QE4 that Tyler was talking about before with that big 600 volt jump and all of our new mechanical systems in there as well, that's been like a massive monumental jump for us. So our next iteration will be looking at like refining that and building incrementally. So most teams generally look at sort of a 2 to 3 year design cycle. So they'll do a big jump every 3 years and then look at refining that and really extracting what they can from the vehicle. So we have to manufacture a new chassis every year. So the vehicle is fundamentally different, but there's room to optimize that and pull a lot of similarities through. So.
Okay. Well, we've still got plenty of time for our social chat and like asking these guys questions. So a round of applause for them. Thank you very much. Let's really appreciate the effort that you're going to bring this in tonight and to stand up here for half an hour answering questions. That's really appreciated. Tea and coffee, milk's in the fridge, lots of snacks because I know you guys are hungry. So thank you very much, guys, and we'll wrap it up. Thank you.